Hi, this is Nuri. Welcome back. Today, we're going to look at how to track live vehicle positions in Mapify using real-time data. As you can see in this example, we're tracking vehicles whose data is being updated live in Mapify. Not only are receiving their positions, but also sensor data like speed, door status, and direction. So how does this work? It all starts with data feeds. That's how Mapify receives real-time data. You can connect via HTTP or MQTT. Mapify can either call an external API or receive data through its own API. In the case of MQTT, Mapify can provide a virtual broker or subscribe to an external one. In our example, we're using an external broker from DigiTransit, the public transport provider in Helsinki. They offer real-time data for vehicles across several cities in Finland through an open MQTT broker. Each vehicle shares its location at high frequency, sending updates every second. These updates include location, speed, direction, and door status. To access this data, you simply subscribe to the DigiTransit's broker. To do that, you'll need the broker address, which is publicly available. You'll also need to subscribe to the correct topics, depending on whether you want data for a specific vehicle, a group of vehicles, or a type of vehicle like buses or trams. DigiTransit provides documentation that outlines these topics and the available event types. Here, we're interested in messages of type VP, which stands for Vehicle Position. In the documentation, you'll find an example of VP message and a breakdown of each field. Important ones include latitude, longitude, speed, and heading. If the GPS signal is lost, say the vehicle is in a tunnel, these values might show up as null. Now let's head into the Mapify console. We start by creating a dataset that will receive the current status information of the vehicles. It's a point-based dataset designed to store coordinates. We also define fields for speed, heading, and a unique vehicle ID, along with a text field for the timestamp, so we can track when each update was received. Next, we create a real-time layer connected to this dataset, which will show the vehicle positions as they update. From here on, Mapify is ready to receive and display the data. Then, we configure a data feed. In this case, we already created one in advance. It's a pool-type data feed using MQTT to connect to DigiTransit broker. We enter the broker address and specify the topic for VP messages, specifically for buses. We also define a schema that tells Mapify how to interpret the incoming messages. This is based on DigiTransit's format. With that done, we move on to creating a workflow. This will handle the incoming messages containing vehicle data and their locations, and store them in the dataset we created. In addition to the node responsible for updating the data, we added a few extra nodes to enhance and streamline the processing quality. For example, we use a filter node to skip any messages where latitude or longitude is null. That way, we're not updating vehicles with missing coordinates. We also compose a unique ID for each vehicle by combining its operator code and vehicle code. This avoids conflicts between vehicles that might have the same ID and their different operators. Essentially, we combine the operator code with the vehicle code into a single string to generate a unique identifier for each vehicle. Then, to properly update a vehicle's position in the dataset, the first step is to select the correct dataset where the incoming message data will be stored. Then, in the geometry section, which is optional, we specifically enable the update of latitude and longitude. We map the incoming fields to our dataset, such as timestamp, speed, direction, heading, and of course, the GPS coordinates. For example, for latitude, we pull the value from the lat field, as defined in the documentation. To let Mapify know which vehicle to update, we set the key field. This matches the ID in the dataset with the one created by the vehicle ID node. You can preview the ID here to make sure it's correct. Then we map the additional fields. Once that's set up, our workflow starts running. Now, if we go to our map layer, you'll see the vehicles updating real time. For visibility, we style them with the bus icon. As you can see in the preview, both the coordinates and sensor values are being refreshed live. To give you an idea of scale, this workflow was created with just a few clicks in just a few minutes, and it's currently processing between 2.5 and 3 million messages per hour. You don't have to worry about scale, Mapify handles that for you. So as you can see, updating vehicle positions in real time with Mapify is simple, is powerful, and fast. Thank you for watching, see you in the next one.